In this exercise, we're going to be highlighting the difference between average velocity, instantaneous velocity, and as well as the speed. Now, in a previous lesson, I have explained the difference between the average rate of change over a period of time and the instantaneous rate of change at a specific moment. And the fact that the velocity is considered to be the rate of change of the distance over a period of time or at a specific instant, then the average velocity and instantaneous velocity are actually seen as an average rate of change and an instantaneous rate of change. So it's good to revisit the other lesson in order to see how the average rate of change and the instantaneous rate of change were explained and compared. So in this exercise, we have a diver that jumps from a platform at time t equals to 0. And the distance in meters of the diver above the water at time t seconds is given by s of t equals to this quadratic function in terms of t here. So in fact, if we consider this to be the surface of the water and this to be the platform over which the diver jumps at t equals to 0. Now in part A, we're asking to find the average velocity of the diver during the dive. Now during the dive, that is starting from where he jumped out of the platform at t equals to 0 all the way to the moment he hits the surface of the water. So I need to determine the average velocity over that period of time, starting from t equals to 0 up to the value of t the moment the diver hits the water. So before I actually find the average velocity, I need to determine the value of t at which the diver hits the surface of the water. Now, since s of t represents the distance between the diver and the surface of the water, then the moment he hits the water, s is equals to 0. So in fact here we need to determine the value of t for which s of t is equals to 0. So by setting this quadratic equation equals to 0, you can use your GDC in order to solve that equation. So by setting that equation equals to 0, we'd determine t equals to 2.01354 seconds. Now, of course, this equation would admit a second solution. However, it would in fact be negative and it would be rejected since time here is positive. So we would simply accept the positive solution. Now over here I did consider 5 decimal places for a reason that I'm going to be using this value of t later on in my calculations. So the more decimal places you'd consider, the more accurate your answer is, the more you reduce the error of approximation, the error that results from approximation from one step to the other one. So for that reason, I'm trying to be as accurate as possible by considering as many decimal places I could. So now that I know that at approximately 2.01 seconds, the diver hits the water, I need to determine the average velocity during the dive. Now, if I were to be drawing the curve representing this dive, then in that case, now that is a quadratic equation that is bending downwards. So over here, what I would really be finding is the slope of the segment that joins these 2 points on the curve. By definition, that is the average rate of change over a period of time. So over here, in order to determine that slope, what I would basically do is for the average velocity, what I would basically do is find s of 2.01354 minus s of 0 divided by 2.01354 minus 0. So that's the slope formula. because what I'm really doing here is determine the slope of the segment joining these 2 points on the curve. That is the average rate of change between 2 points in a specific model. So evaluating this on your calculator, that would give negative 4.97 meters per second. However, for part B, they're asking for the velocity of the diver at the instant the diver hits the water. Now, we're no longer interested in the average velocity over this whole period of time. I'm just interested in the velocity the moment he hits the water, which is at t equals to 2.01 approximately. So, in fact, that is referred to as the instantaneous velocity, and as explained in the previous lesson, that instantaneous velocities are represented by the derivative of the function at that specific point. So over here, by just perhaps considering this to be the curve representing the dive, so at 2.01 seconds, if this is t, this is s. So at 2.01 seconds, the velocity, the instantaneous velocity, is in fact determined by the tangent vector to the curve at that specific point. It would in fact give you the magnitude and the direction of the vector that would define the instantaneous velocity. So over here, in order to determine the instantaneous velocity, I need to find s prime of 2.01354, where s prime would in fact be the derivative, the velocity of the derivative of the distance or the displacement. So over here, to find the derivative, s prime of t, which is v of t, is 4.9 times 2, that's a 9.8, so that's a negative 9.8 t plus 4.9 t, and then we have, plus 4.9, the derivative is 4.9. Then over here, the constant tan has a derivative equals to 0. So replacing t by 2.01, that would lead to an instantaneous velocity of negative 14.8 meter per second. So here, in fact, by looking at the instantaneous velocity, referring back to the tangent vector at that specific point, the norm or the magnitude of that vector would be 14.8. However, the negative represents the direction of the vectors, the vector, as the vector here is pointing downwards since the diver is moving downwards towards the water. So in that case, the instantaneous velocity is negative. However, the 14.8 will be representing the magnitude of that vector. Which leads me to part C, where they ask to find the speed of the diver at the instant the diver hits the water. So we're still at the same value of t here, the moment the diver hits the water. So the speed is, in fact, represented by the absolute value of the instantaneous velocity, which graphically it is the magnitude of the velocity vector, the one that is tangent to the curve at that specific point. So for the speed, in order to determine the speed at that specific value, that would be the absolute value of negative 14.8, which is 14.8 meters per second. So the instantaneous velocity is in fact an oriented speed. So the speed gives the magnitude of the velocity vector. So it would tell how big or how little is the change in distance happening. However, the instantaneous velocity does give me the orientation or the direction of the velocity vector, if it's pointed downwards or upwards, which in this case, since we're considering a dive, then the diver is pointed downwards, is heading downwards. So this is why the instantaneous velocity is negative. And the speed eventually would just be not considering the direction of the velocity vector, will be just interested in the magnitude of that velocity vector there.